Today we're going to talk about writing equations for lines. And to start, let's remember the two forms of equations that we learned, and one was general form. Which is also called standard form, so general or standard form. And that is ax plus by equals c, where a, b, and c are integers, not fractions or decimals, and the a must be positive. An example is right here, 3x minus 2y equals 4. We also have slope-intercept form. And slope-intercept form is y equals mx plus b, where m and b can be anything including fractions or decimals, but the coefficient of y must be a positive one. So in an example is here, y equals negative 3/2 x minus 2. So those are our two forms of equations for lines. Typically, when I have you write an equation for a line, I will tell you the form that I want it to end up in. So if I want you to end with standard form, I will tell you that. The reason why is for checking purposes. Because if some of you write it in slope-intercept form and some of you write it in standard form, when I say the answer, we're not all going to know if we've got it right or not, because it may be in different forms. On top of that, you may have it in no form whatsoever. Doesn't mean it's incorrect, it just means it's not in the appropriate form. And that's why our goal is always to end with our equations in the same form. You'll find that in general, I tend to tell you to make it in standard form so that we're all the same. We're going to learn 3 ways to find an equation for a line. And the method that we choose depends on what type of information that we have about the line. The first method that we're going to use is the easiest. And this is if you know the slope and you know the y-intercept. And the slope, remember we said, is m. The y-intercept is the point B, or as coordinates, it's 0b. We can use the slope-intercept form, y equals mx plus b, and we're going to do this so easily. We're going to plug the m right here and the b right here, and we have an equation for a line. So our first example says find the equation of a line that has slope of 1/2 and a y-intercept of 0, negative 4. Remember, that -4 is our b. We're going to start with the equation y equals mx plus b. The 1/2, the slope, is our m. The -4 of 0, negative 4 is b. So all we have to do is plug in m and b, and we get y equals 1/2 x minus 4. It's that easy. Typically when I have you use this method, I don't have you change it into standard form. I just have everybody leave it this way. But in a question, especially on a test, I'll tell you how I want it to end. All right, let's go to the next page, and we're going to do a few examples of this. So, example 2a, slope is negative 3/2, y-intercept of 5. So the negative 3/2, this is our m, our slope. A y-intercept of 5 means 5 is the b. So we're going to start with y equals mx plus b, and we're going to plug in m and b. So we have y equals negative 3/2 x plus 5, and we are done. Example B, we have a slope of 4, and it goes through the point 0, negative 2. It happens that if we have a 0 in the x position, this is the y-intercept. All right, so the y-intercept is 0, -2, and that means the -2 is our b. The 4 is our m, the slope. So we're going to start with y equals mx plus b. We're going to plug in the m and the b. So we have y equals 4x minus 2, and we are done. Pretty easy. The next method is going to take a little bit more work on your part. So the next method applies if you know the slope and one point on the line. Okay? So the slope, and remember the slope is m, and our one point, we're going to call that x1, y1. All right? What we're going to use in order to do this is a formula. And the formula is y minus y1 equals m times x minus x1. Okay, that's our formula. And so here's what we're going to do. We're going to label everything, plug it in, and then we're going to put everything in standard form. So first of all, it says find the equation of the line that passes through the point 3, 4, that's x1 and y1, and it has slope of 2, that's our m. Start with the equation or the formula, y minus y1 equals m times x minus x1. We're going to plug in y1 here, m here, and x1 here. So I have y minus 4 equals 2 times x minus 3. All right, next thing I want to do is simplify this. So I'm going to distribute. I have y minus 4 equals 2x minus 6. I want to get all of my terms that are similar together, so I'm going to move this 4 over to the right-hand side. So I'm going to add 4 to both sides. When I do that, I've got y equals 2x minus 2. I happen to have my equation in slope-intercept form, but most of the time I'm going to tell you put it in standard form. So let's go ahead and do that. My x's need to be on the other side, so subtract 2x on both sides. And I have negative 2x plus y equals negative 2. But I can't have a negative as my a. So I'm going to divide everything not by negative 2, but by negative 1. The 2 is okay, it's just the negative that can't be there. So everything is divided by negative 1, and I'm going to get 2x minus y equals 2. And that is standard form. So clearly, this takes a little bit more work to accomplish. So let's go ahead and do another example. So we have find the equation of the line with the given information. Give your answer in standard form. So first of all, I have the slope of negative 3. My slope is always m. Through the point 2, 1. So this is x1, y1. And what I'm going to start with is my formula, my point slope formula, which is y minus y1 equals m times x minus x1. I'm going to plug in the m, the x1, and the y1. So I have y minus 1 equals negative 3 times the quantity x minus 2. Now I need to simplify this. So I'm going to go ahead and distribute, and I have y minus 1 equals negative 3x plus 6. I want all my constants together, so I'm going to add 1 to both sides. And I have y equals negative 3x plus 7. So that's in slope-intercept form. But what I want to do is end in standard form. So I need to move my x's to the other side. So add 3x to both sides. And I have 3x plus y equals 7. And there's my equation in standard form. All right, let's do another example. So we have b here with a slope of 4/5 and through the point -1, 0. All right? First of all, any point that has a 0 in the y position is actually an x-intercept. So this happens to be an x-intercept. But we're still going to call it x1 and y1. And the 4/5 is the m, the slope. So now I'm going to use my formula. Y minus y1 equals m times x minus x1. And so I have y minus 0 equals 4/5 times x. Now if I have minus a -1, that's really the same as x plus a +1. Now, I'm eventually going to want to put this in standard form. Here's what I don't want in standard form: fractions. So before I distribute, I'm going to get rid of my fractions by multiplying both sides by the denominator of 5. So I'm going to multiply by 5 right here and over here. Now, obviously, y minus 0 is just y. So on the left, I just have 5y. On the right-hand side, these 5's cancel, and I'm just distributing the 4. So I have 4x plus 4. Now I'm going to put this in standard form, so I need my x's on the left, so subtract 4x on both sides. And the only thing left is I can't have a negative here in front of my a term. So instead of divided by -4, the 4 is fine, just the negative needs to go away. I'm going to divide everything by -1. And so what I'm going to get is 4x minus 5y equals -4. So there's my equation in standard form. All right, let's take a step a few pages ahead, and let's go to page 20 and address horizontal and vertical lines. Now, horizontal and vertical lines are easy. They are so easy, but the issue is you have to realize that you're dealing with a horizontal or a vertical line. So again, here's what we know about horizontal lines. They have the equation y equals a number. There are no x's in the equation. No x's in the equation. All horizontal lines have the slope of 0. Okay? This is so easy. We have an example. It says, find the equation for a horizontal line passing through the point -3, 2. All right? Here's what I'm going to do. Let's draw -3, 2. It happens to be right here, and I have a line going through it. A horizontal line that goes right through it. Here's how I write that horizontal line. My equation, remember, is y equals a number. Well, if you go to the coordinates, what is the y value? It's 2. So my equation is y equals 2. That's my whole equation for my horizontal line. And notice, it's a horizontal line. It goes through this point, and it passes through the y-intercept of 2 on the y-axis. Hence, y equals 2. Vertical lines are also easy. Remember, vertical lines come in the form x equals a number, and there are no y's in the equation. So we have no y's in the equation. Remember, all vertical lines have undefined slope. This is why you have to remember this method for finding equations for vertical lines, because every other method that we learn, you have to put in m for slope. Well, slope is not a number, so there is no number that you can put in for slope that will give you a vertical line. So you have to remember this way of finding an equation for a vertical line. Remember, it's x equals a number. Here's an example. At the bottom of the page, we have find the equation for a vertical line that crosses the x-axis at the point 3, 0. So we're going to plot 3, 0. It's right here. There's a vertical line that goes through it. Remember, the equation for a vertical line is x equals a number. Go to our coordinate. The x value is 3. So our equation for our vertical line is x equals 3. And notice, it's a vertical line that passes through 3 on the x-axis. Now the interesting thing, we've learned to use the point slope formula, and I want to show you where that comes from, because it doesn't come from nowhere. So let me write down the point slope formula. Here we go. And what I'm going to do is I'm going to use algebra and manipulate it a little bit. And what I'm going to do is divide both sides by the same exact thing. And what I'm going to divide them by is what's in parentheses here. X minus x1. Here, these now cancel on the right-hand side. Same thing in the numerator and in the denominator. And if you look and see what I have m equals y minus y1 over x minus x1. And this formula should look familiar to you. This looks just like the slope formula when you have 2 points. And that's in fact where this does come from.